So this is question number 2.1 of class 12th, and that chapter name is electric potential and capacitance. We'll going to get the solution here. But first of all, let's see what this question, this chapter contains. So from here to here in this, while you see this index, from here to here, from 2.1 to 2.6, you are going to learn about potential, solo potential, right? Then after, from in this two section, you are going to get to learn about the potential energy, and from 2.9 to the end you are going to get to learn about capacitance, right? So these three things you are going to learn in this chapter. And particularly this question has arisen from the topic potential due to a system of charge 2.5, you can see here, right? So in this particular topic, what we are going to learn, that let's I am writing question number C, concept number 1. So what is here, that is, if you have charge q1, q2, sorry, q3 and q4, and at that point p we have to find that potential. So the potential that you are going to get because of all these charges v1, v2, v3, let's say because of charge 3 and v4, the v total you are going to get is the algebraic sum of all this potential, right? So this is the concept, and the potential is equal to k q by r, right? So this is the concept that is in this topic. Now let's solve this question, and you are going to find that this question is very easy. So this is the, I'm going to clear the screen, and now let's solve this question. So first of all, write given that q1 is equal to 5 into 10 to the power minus 8 coulomb, q2 is equal to minus 3 into 10 to the power minus 8 coulomb, and r is equal to 16 centimeter. And don't do mistake, you have to convert it in SI unit, that is 0.16 meter, right? So after that, let's draw a diagram to understand this thing more clearly. So do this from different color, and I am making this q1, and from here to here, that is q2. Okay, so q1 and this is q2, right? And let's say that at point p, this is the point p where vt is going to be 0. So from here to here, the distance is r, that is given in question. But now let's assume that from this point to this point, let's say that this is your 0 in Cartesian coordinate, and you are assuming that from this point to this point the distance is d. So obviously if this is d, this is the length is d, so this is going to be r minus d. Okay, no problem. And here is one catch: if you are assuming this d and this is r minus d, then you are going to get the opposite answer of these things, right? So keep in mind and try to solve this way, because in Cartesian coordinate you will going to get a distance from 0 to that point, right? Don't take from this side to this side distance, you will take distance from 0 to this side, right? So try to assume that d from this 0 to point p. Okay, so keep in mind, you will going to get a good answer. Now solving this question, after that what you have to do, so first of all what you have to do, you have to align this diagram so that you will going to find easy in understanding, right? I have aligned it. Now let's solve this question. So this is going to be, first of all I will write the concept that I am going to use. So concept I am going to use is, so the total potential at point P due to charge q1 and q2 is the sum of individual potential at the point due to Q1 and Q2. This is going to be your statement. Now by using this statement, you can write the equation. That equation is V total is going to be V1 plus V2. Clear? Now writing that V total is taking the value of V1, that is K Q1 by R1, and V2 is K Q2 by R2. And don't get confused with R1 and R2. R1 is the distance between Q1 and P, that is this, and R2 is the distance between Q2 and P, that is this, right? This is R2 and this is R1. Okay, clear? Now I am going to put the values that I have. So V total is equal to K Q1 Q2. Let's for the simplifying this equation, I am going to take Vt is equal to 0. Vt is equal to 0. That is given in question. That what we have to required. That is that point P. The Vt is going to be 0. So at point P, the Vt is going to be 0. So I am writing it 0. 0 is equal to K Q1 by R1 plus K Q2 by R2. Okay. Now I am rearranging this equation, that is minus K Q1 by R1 is equal to K Q2 by R2. I have just taken this term this side, left hand side. Okay. Now I am putting this values. Let's first of all eliminate the term that we can cancel out. Now putting the value, that is Q1 is 5 into 10 to the power minus 8 by R1 is going to be D. D is equal to Q2 is minus 3 into 10 to the power minus 8 by R2 is R minus D. Okay. Now eliminate the possibles. So let's I am eliminating this with a red mark. So minus and minus will going to eliminate in first place, then 10 to the power minus 8 and 10 to the power minus 8, and now we have to rearrange it. So 5 R minus D is equal to 3D. Okay, and now we have 5R minus 5D is equal to 3D. So 5R is equal to 8D, and we know the value of R. So 5 into 0.16, right, the distance between these two charges, and 8D. Okay, so 5 into 16 is going to be 16 pache 80, right? So that is going to be 0.8, and 8D, and D is equal to now 0.1, and that is in meter. So this is particular value that you are going to get. And in centimeter, what is it? It is 0.01 centimeter, right? So this is particularly 0.01, sorry, I am so sorry, this is 10 centimeter, right? This is 10 centimeter, and that means that the value here, the value you are getting here, and let's see in this particular diagram. So I am taking different color. So this is the value here from here to here, that particular D you are going to get 10 centimeter, and if this is 10 centimeter, then R minus D is going to be 16 centimeter minus 10 centimeter, and that is going to be 6 centimeter, right? So this is the thing. Okay, so this is the value that you are going to get. The d from this to this is 10 centimeter. So at 10 centimeter, at 10 centimeter from q1, the potential is going to be 0. So you can write at 10 centimeter, at 10 centimeter from q1, the total potential is 0. All right, and now let's solve for the, take the point at infinity to be 0. So this is your particular thing, but there is also one thing here. It is going to be 0. There is also one point where it is going to be 0, where if I am considering a point that is outside this system, if I am considering a point that is outside this system, because what the question has asked, the points, it has asked, right? So there are so many points at which the potential is going to be 0. So here it is going to be 0, and it is also going to be 0 outside the particular system. So for that also we have to solve. So for if we are considering the particle outside the system, if the point outside the system, then what we are going to do? So let's again make this diagram. So this is the q1, this is the q2, this is q1, this is q2, and point outside this system, let's assume here this point, here the potential is going to be 0. So let's assume that this distance from here to here, the distance is d. Okay, and this distance is given in question, that is r, right? So this distance is going to be d minus r, right? Now let's solve this question again for this by using the same concept. By using the same concept we have to solve. So first of all, the given thing is you have written in the first place, right? So now we are going to solve this question from writing that concept statement 1, that is sum of the total potential at that point P is going to be sum of all the potential at individual potential of Q1 and Q2. I am writing the equation now, that is V total at point P is equal to V1 plus V2, right? So V1 is K Q1 by R1, and V2 is K Q2 by R2. Now rearranging, I am rearranging this to get a simple calculation. So by rearranging, minus K Q1 by R1 is equal to K Q2 by R2, right? Okay, so now what we have is the K and K is going to be cancelled out. So minus Q1 by R1 is going to be Q2 by R2, right? And now by putting the value, that is minus Q1 is 5 into 10 to the power minus 8 by R1 is going to be this. R1 is this D1. R1, the distance between Q1 and that point, right? And R2 is going to be this, the distance between Q2 and P, right? So the distance between Q1 and P is D, and the distance between Q2 and P is minus 3 into 10 to the power minus 8 by the distance between in Q2 and P is D minus R. Okay, so after that we can cancel out this particular negative signs, and then 10 to the power minus 8, 10 to the power minus 8, and then after that 5d minus r is equal to 3d. So that is 5t minus 5r is equal to 3D, and that is 3 means 2D is equal to 5R, and the value of R we know, the value of R is 0.16. So 5 into 0.16, right? So by solving it further, we are going to get D is equal to 5 into 0.16, that is 0.8 by 2. So that is, you are going to be 0.4, right? So that particular D you are going to get here is 40 centimeter, right? So from Q1 at a distance 40 centimeter, the potential total is going to be 0. So this is your particular answer. So this is the way you can solve this question, and you are going to get full marks in your exam. You have to just write the statement, given that statement, then diagram, and then the procedure you have to follow, and you have to write the right answer here. So from here to here, the distance D is going to be 40 centimeter for getting that particular V per total is 0, potential total is 0, right?